Yes, hi everyone. Good afternoon, all. So today, let us we discuss the syllabus and introduction part of Power Systems 2 subject. This is one of the important subject for electrical and electronics engineering students. As you are in the third year, this is the core subject and very important. So for your the other degree, that means after the B Tech and after your M Tech also, this Power Systems 2 subject is very important. And already you studied about power systems 1 you studied, and in the power systems 1 you studied about the generation of the power system, generation of electrical power, how we generate the power, what are the various types of electric power generating systems are there, and in detail about that you have seen in PS1, that is power systems 1. At the same time, we have seen the various aspects about tariff also. Tariff, tariff also. That is how we can calculate the tariff. So all those things we have seen in the power systems one subject. That means in the second year, just they introduce the power system. Now, in the third year, so right now we have the power systems 2 subject as well as power electronic subject also. Power electronic in the sense that is electric power combination with electronics. That is which interlinks both the electrical and electronics. And next the other subject, that is power systems 2 subject. If you see here in this power systems 2, the mainly concentration, we mainly concentration about power transmission system design. That means after generating the power, so we need to transmit the power to the destination. For such transmission we need some system. So such system is power transmission system. In this power transmission system, so what we need to transmit, which type of power we need to transmit, and how the transmission line has to be constructed, so all these things we used to see under this power systems to subject. And if you see the introduction of this subject, and this course is an extension of power systems 1 course. As I told you already, it deals with the basic theory of transmission lines modeling and their performance analysis. That means transmission lines modeling, how we model the transmission lines, and how we can estimate the performance. Performance in the sense, for our any electrical system, how you can grade the performance. You can grade the performance based on two aspects. One is efficiency of the system, and another one is regulation of the system. Yes, what are the two? The first one is efficiency of the system, and the second one is regulation of the system. Now, how you can expect the good performance system? The efficiency must be high as much as possible, and regulation must be low as much as possible. For any good performance system, we expect high efficiency and low regulation. The third one is the transient in power system. Improvement of power factor and voltage control are discussed in detail in this course. That means transient in power system. Yes, what do you mean by transient? Transient in the sense when the system is subjected to sudden changes. When the system is subjected to sudden changes, that means the voltage may be changes suddenly, the current may be changes suddenly, that is the load may be changes suddenly. Then how the system affect, and how the entire system affect, and for such a system how we can hold the power factor of the system, and how we can control the voltage. So all those things we used to observe in detail in this power systems 2 subject. And it is also important for the student to understand the mechanical design aspects of transmission lines, cables, and insulators. Yes, it is very very important. Why the transmission lines, cables, insulator, all these are required? Why insulators are required? Because we cannot construct the single transmission line over the kilometers. Suppose, for example, now we are generating the power at Vijayawada, and that power has to be transmitted to the Chennai. Let us we assume like that. The power is transmitted to the Chennai. And can I construct the single wire, so which has to be carry the total power from Vijayawada to Chennai without any stops? Is it possible? Yes, is it possible? I think it is not possible. It is not possible. So therefore, what we need to do for at fixed levels, we need to construct the poles. So in order to strengthen the pole, you need to design the insulators. Because if suppose the wire, the conduction has to be go down, then what happen? The people who are under the tower, they will get the shock, electric shock. In order to avoid all those things, so we need the insulators. So therefore, these concepts, that is the mechanical design aspects of the transmission lines and cables and insulators, so also observed in this power systems 2 course. So therefore, what is power systems 2? It is just extinction of the power systems 1. And moreover, so here in this course we need to see the power transmission system design. Power transmission system design. Less. Now let us see the syllabus. In the first unit you have the transmission line parameters, that is transmission line parameters and conductor materials. Yes, transmission line parameters. Now you have the various types of electrical networks are there. Electrical network elements are there. What are the various types of electrical network elements? Those are, the first one is active and passive elements, linear and non-linear elements, and the next one is unilateral and bilateral elements, and the other category is lumped and distributed elements. Yes, what is the other category? Lumped and distributed elements. And while you are studying the circuit theory deals the electrical circuits, and moreover that circuit elements are lumped elements only. That means if we want to apply KVL, KCL, Ohm's law, all these things can be applicable for the lumped parameter networks only. It is not applicable for distributed parameters, distributed element network. So hence, while we are analyzing the performance of the transmission system, so the KVL and KCL fail. Both KVL and KCL are failed. Then what is the remedy for that? What is the remedy for that? So here you need to see about the field concept. Field concept, in the sense, already you studied the field concepts in second year, that is electromagnetic fields. Okay, now you tell me what is the difference between electromagnetic fields and electric circuit, that is circuit theory, field theory. What is the difference between these two? The circuit theory deals the circuits so up to 1 megahertz of frequency, that is maximum. But the field theory can deals so both below 1 megahertz as well as above 1 megahertz. Okay, and the second one is, in the case of circuit theory, we have only two parameters to analyze the system. Yes, what are the two parameters? One is current and another one is voltage. But if you see in the case of field theory, so there we have many parameters are there. What are the many parameters? Electric field is there, magnetic field is there, electric field intensity, magnetic field intensity, electric flux, magnetic flux, electric flux density, magnetic flux density, electromagnetic field, that is Lorentz force equation, that is electric force, magnetic force. So like that we used to see the many parameters in the case of field concept. Okay, now you tell me which is the best system to analyze to estimate the performance of the system. That is field theory only. Why it is? In the case of circuit theory, it is fail. It is having only two parameters, two elements to estimate the performance. But whereas in the case of field theory, you have the many parameters are there. That means suppose one element is there. I want to know the performance of this element. If I know only what is the height and what is the width, then I don't know what is the I don't know the exact performance of this element. But if I know what is the length, what is the breadth, and what is the volume, at the same time what is the characteristics, which type of field is there, either electric field or magnetic field, and how much intensity is there, and if I calculate all those things, then I can easily estimate the performance of the system. So therefore, so generally in the first unit we prefer the field concept. So therefore you need to remember the field concept before we enter into the PS2, that is first unit. And here also we have various types of materials which we are used in the conductors for the transmission system. Generally you know about aluminium, copper, and beyond that also we can use. So we'll discuss in detail, so while we are discussing the types of conductors. And the second one is what are the distribution system. As already I told you, lumped parameters are there, distributed parameters are there. What are the distributed parameters? Lumped parameters in the sense the elements which are used in the circuit theory, that are network theory. So those elements are lumped parameter. That means resistor, inductor, capacitor. Those three are lumped elements. Then what about the distributed elements? Distributed elements are transmission line parameters. Yes, what are the distribution elements? Distributed elements are transmission line parameters. Yes, what are the transmission line parameters? Again, transmission line parameters are resistance per kilometer, inductance per kilometer, capacitance per kilometer, conductance per kilometer. Yes, it is very simple. Yes, what are the transmission line parameters? Resistance per kilometer, inductance per kilometer, capacitance per kilometer, and conductance in the sense which is the inverse of resistance zone. Now we need to estimate what is the resistance of the transmission line, and what is the inductance of the transmission line, and what is the capacitance of the transmission line. So we need to find all these things. So this will comes under the first unit. Okay, now you see types of conductors, calculation of resistance for solid conductors, calculation of conductance, calculation of inductance for single phase and three phase, single and double circuit lines, concept of GMR and GMD, geometrical mean radius and geometrical mean diameter, symmetrical and asymmetrical conductor configurations. All these things we can see under the first unit. Okay, and moreover this first unit is somewhat lengthy unit, it will take much time, and second third are very simple. Okay, yes, in the second unit you can see performance of short, medium length transmission line, because the transmission lines may be connected, maybe up to 50 kilometers, maybe up to 150 kilometers, maybe up to greater than 150 kilometers. So therefore, we may have the various types of transmission system. Those are short transmission lines, medium transmission line, and a long transmission line. So in the second unit, we used to see the short transmission system and medium transmission system performance. Performance in the sense I already told you. So we need to find out the efficiency and regulation of these lines. Okay, so we'll see in detail later. The next third unit. The third unit is exclusively performance of long transmission system. Long transmission system. And moreover, for second unit and third unit, you need to refer and remember the two-port network parameters. In the two-port network parameters, we have the transmission line parameters. Yes, the transmission line parameters knowledge is required for both second and third unit. Okay. Yes. In the case of fourth unit, we have the power system transients. Power system transients in the sense how the power system affected by the transients when it is subjected to the sudden changes, when it is subjected to the sudden changes in voltages, in currents, all those things we used to observe in the power system transients. Okay. Yes, the next one is various factors governing the performance of transmission line. That is, we have the mainly skin and proximity effects. Skin and proximity, these are very beautiful. So while we are seeing, so we can observe this, and daily you are observing at the outside also the skin and proximity effect, especially the skin effect you can observe, and that is the corona also. Corona is there. Corona used to observe in the transmission line, that is overhead line. So like a hissing noise, zzz, like that, used to observe that system. So we will discuss in detail about this. And the last unit is sag and tension calculation and overhead line insulators. So generally in the previous, that is for before regulation, so this was the two units, that is insulators was one unit and another one is sag and tension calculation is one unit. But here these two are merged. These two are merged. So hence we have the sag and tension. Sag in the sense this is one pole, this is another pole. In between these two poles, the transmission line is connected like this. That is called sag. How you can calculate that sag, and how you can calculate the strength, that is the tension of the sag. So we will see in detail about that. Now finally, so what you can get from this subject in the sense, the first one is you are able to understand the parameters of various types of transmission lines during the different operating conditions, that is resistance, inductance, capacitance, and you are able to understand the performance of short and medium transmission line, that is short transmission line and medium transmission line efficiency. And the next one is yes, efficiency and regulation. And you will be able to understand the traveling waves on the transmission, that is the transients, and you will be able to understand the various factors related to charge transmission line. You will be able to understand sag, tension of transmission lines and performance of the insulator. So these are the outcomes for this subject. Okay. Now, the textbooks, what you need to refer is Electrical Power Systems by C.L. Wadhwa. And if you want, I will send this entire textbook to you as soft copy. So you may have this. The entire system is present. Entire Power Systems 2, Power Systems 1, and next what are the subjects. So belongs to the power systems. All those subjects will be present in the textbook. I will share that textbook to you as a soft copy, and there are many textbooks are there from 2 to 6. So these also important, And apart from these six subjects, so these six textbooks are referred by the as given by the university. And apart from these six textbooks, there is one more textbook, so which is Mehta, VK Mehta, Electric Power Systems by VK Mehta. So that is very simple. The textbook is very simple. I will share the textbook also with you later, okay, as a e-copy. Yes. Now, let me introduce about the power system. Now, what is the structure of power system? As we know, the power system, the power system like this. There are three components are there. What are those three? First one is generation. Second one is transmission. Third one is distribution. Power generating system, power transmission system, power distribution system. Okay, now let me know what are the things present in the power generation. In the case of generation, we have the generators. The generators will generate the power, and then that power has to be step up. While the power has to be step up, that means in the terms of voltage, why the electric power has to be transmitted at a high voltage level? Because the power, in the sense, it is the combination of voltage and current. What are the power losses? The power losses are copper losses. Power losses are copper losses. Copper losses are I square R losses. I square R losses. I square R loss. If current is more, then loss is also more. Therefore, what we are doing here in the case of transmission, we are step up the voltage. So when we step up the voltage, the power is constant, hence the current value is decreased. So thereby the power loss is reduced in the transmission system. Okay. Next, in the transmission, we transmit the power from generation to the distribution. Yes, in the distribution, so we have to distribute to the consumers. So this is the actual power system what you have studied in the PS1, and what I supposed to tell you the same thing. That means the power has to be transmitted. The power flow diagram is like this. It has to be flow from generation to transmission, transmission to distribution, like this. Okay. Yes. That means this is the power generation, and here this is the transmission, and here this is the distribution. That is distribution, power generation, transmission, distribution. Okay. Yes, in the distribution, we may have the lights, you may have the fans, you may have the industries, you may have the ACs. Yes, all those things you have at the distribution. Okay. Yes, for example, apart from the distribution, I have the load, so which is present very near to the generation, and which is present very near to the transmission. Which is present very near to the transmission. In that case, so how I get the power from this 1 and 2? Yes, how I get the power? As per the regulations, I need to get the power from like this, next this, from here to here, I need to get the power. Then how much copper is wasted? How much copper is wasted? So hence, what I do in the sense, I can get the power directly from the generation. And here also, I can get the power directly from the transmission. That means the entire power system has to be changed. That is, the rules and regulations of the power system has to be changed. Rules and regulations of the power system has to be changed. Such power system is called deregulated power system. Yes, so nowadays we have the power system, so which is deregulated power system. Just you tell me. So nowadays, which type of power system you have? Deregulated power system. Yes, in the deregulated power system, what is the change? Yes, in the conventional, that is ordinary power system, the consumer has to get the power only from the distribution. But whereas in the case of deregulated power system, the consumer may get the power directly from the generation, or directly from the transmission, or directly from the distribution. So thereby we are decreasing the cost. And while we are decreasing the cost, some other parameters affects the power system. Yes, that is the other concept. Some other parameters affects the power system. Yes, so how it will be affect? All these things we should know. If time permits, so I will discuss with you at the after the completion of the subject. Yes, now what is deregulated power system in the generation point? Generation point in the sense, yes, the power may be generated by either solar, either wind, either thermal, either nuclear, either hydel, whatever it may be. So whatever the type of generation, so I can use. And if suppose today I can generate the 2 megawatts of power, and tomorrow I can generate the 10 megawatts of power, and day after tomorrow I do not generate the power. Yes, do you got my point? This is the deregulated power system subjected to the generation. Subjected to generation, what I can do? I can generate as per the rules and regulations. I cannot generate the power as per the rules and regulation. And in some cases, I do not generate the power. In other cases, I can generate the power more than its requirement. So this is called the deregulated power system in the generation point. Yes, next, what is deregulated power system in the transmission point? Transmission point in the sense, the power can be transmitted either from generation to distribution, or either from consumer point to the other generation, either from consumer point to the distribution. Yes, whatever it may be, whatever can be possible. That is in the case of deregulated power system subjected to the transmission point. And distribution in the sense, distribution from the generation we can directly distribute, from transmission we can directly distribute, or after the transmission we can build one distribution system. From there also we can distribute. Then it is very very important. What is that in the sense? Customer point. Deregulated power system in the customer point. In the customer point in the sense, the customer can get the power from the generation. Suppose there are 4 generators are there in one system. This generator used to generate the power at 2 rupees per unit. This is for 10 rupees per unit. This is for 8 rupees per unit. This is for 1 rupee per unit. And which generator you can suggest? From which generator you can take the power? This. That is 1 rupee. So this much of capability, this much of comfortness is there for customer point. Okay, this is the brief about deregulated power system. So the system which is used nowadays, but one system is there which is called ISO, so that used to monitor all these things, all these transactions. Okay, uh, yes, thank you. If you have any doubts you can raise, so I am here to help you. Yes, thank you for watching this class.